These are the video notes for the laws of exponents. And what the laws of exponents are is a set of rules that you can use whenever you're doing different types of operations with exponents. And you'll have these rules and formulas as part of your formula guide on the STAR test. And I have them listed for you here at the top. Let's look at the first example. We have 12 times x to the 8th power times y to the 4th power times z to the negative 3rd power. All of that's being divided by 9 times x to the 5th power times y times z to the 6th power. So since we have a bunch of exponents that are being divided, the rule that's going to be most helpful for us is right here. And this rule is saying that if two exponents with the same base, first exponent, or the exponent at the top minus the exponent on the bottom. Here's what that looks like. First, let's just look at the numbers, the coefficients. We have 12 and 9. 12. Then, looking at the first set of variables, we have x to the 8th power being divided by x to the 5th power. So the base is x. The top exponent was positive 8. The bottom exponent was to the positive 5th power. So if it's being divided, we subtract them. So 8 minus 5. We have y to the 4th being divided by y to the negative 2nd power. So the base is y. The top exponent was positive 4. The bottom exponent was negative 2. So if you subtract them, 4 minus negative 2. Z to the positive 6th. So that's the same thing as z to the negative 3rd minus 6. You would get 4 over 3. Next is 8, x to the 8 minus 5. 8 minus 5 is positive 3, so x to the positive 3rd power. Then y to the 4 minus negative 2. 4 minus negative 2 is like 4 plus 2. So this would be y to the positive 6th power. Then the z's, we had z to the negative 3 minus 6, which is negative 9. From here, the last step is to rewrite this without any negative exponents. So right now we do have one negative exponent. That's z to the negative 9th power. And the rule that's helpful for us here is this one. A base to the negative power is the same thing as 1 divided by, or 1 over, the positive version, as 1 over z to the positive 9th. So now what I'm going to do is I'm going to rewrite what I have here. So I have 4 over 3 x to the 3rd power y to the 6th power, and then I'm going to bring z to the 9th power because it was to a negative power. And then here's my final answer. Let's look at the next example. A times b to the 4th power, all that's being taken to the 3rd power. And then I have 7 times a to the 8th power times b to the 2nd power times c to the 10th power, all that's being taken to the 1/2 power. So in this example, I have powers, this one right here. If one power is being taken to another power, then those two powers are being multiplied together. So let's do that part first. So the 3rd power. So I would do 4 to the 3rd power, then a to the 3rd power, then b to the 4th is being taken to the 3rd power, and I need to multiply those two. So 4 times 3 is 12, so this is b to the 12th power. Thing with the term on the right. But this time, everything in the parentheses is being taken to the 1/2 power. 7 to the 1/2 power a to the, it was 8, that's 8 times 1/2. That's like 8 divided by 2, so 8 times 1/2 is 4, so a to the 4th power. Then b, it was b to the 2nd power being taken to the 1/2 power, so 2 times 1/2, so this is just b to the power of 1, or just b. And then c to the 10th power, 10 times 1/2 is 5, so c to the 5th power. Let's start with just the numbers. So I have 4 to the 3rd power and 7 to the 1/2 power. Everything is getting multiplied together here. So in your calculators, I would do 4 to the 1/2. And that's 169.33. Then I match up terms that have the same base. So I have a to the 3rd power here and a to the 4th power here. The rule that's going to be helpful for me is this one right here. And if two terms with the same base are base, so I would have a to the 3 plus 4, a to the 7th. Then let's look at the next variable that we have, which is b. And here's a b here. So I have b to the 12th plus 1. So b to the 13th. Then what's left? I have the 5th, and there are no other c's. So we're just going to bring c to the 5th here. And this